Multiplying polynomials. Yesterday's lesson we looked at multiplying a monomial by a polynomial and you just distribute that one term. Well, now we're going to take a look at how to multiply when we have, for example, a binomial times a binomial. So our first example, there's two methods to multiplying a binomial times a binomial. One is using distributive property twice. First, you use distributive property with your first term in the first binomial. So a times a gives us a squared, and a times -3 gives us -3a. Then we take the second term and distribute that as well. So 6 times a is positive 6a, and 6 times -3 is -18. So then when we simplify, we combine our like terms. We've got -3a plus 6a gives us a positive 3a minus 18. The second method I'll show you on the second example. And the book calls it the table method. I call it the box method because I set up a box. And in this case, since it's a binomial times a binomial, I need two kind of windows on each side. And then across the top, I put the first binomial, 4c minus 5. Make sure those subtraction signs turn into a negative when you separate your binomials. And along the left-hand side of the box, I put my second binomial, 3c plus 3. And then inside the box, it's kind of like you're finding the area. So you're multiplying the two sides together. So in my first box here, I'm multiplying 3c times 4c. 3 times 4 gives me 12. C times c gives me c squared. In my second box, I have 3c times -5 gives me -15c. In my third box, I have 3 times 4c, which is 12c. And in my fourth box, I have -5 times 3, which is -15. So then when I write my answers, I look for my like terms inside the box. So in my first box, I have a 12c squared with no like terms. In my second and third boxes, I have like terms. So -15c plus 12c is -3c. And in my fourth box, I have -15. So I'm going to use every other method. We've got a few more examples. So this method, I'll go back to distributive property if you want to see that one again. So I'm going to take my first term and distribute it to both pieces in my second binomial. So I have, 4 times 2 is 8. So I have 8h squared. 4h times 5 is positive 20h. And then distributing my -4, make sure you keep that negative sign with. -4 times 2 is -8h, and -4 times 5 is -20. So combining our like terms, we get 8h squared plus 12h, the 20h minus the 8h, and then minus 20. And these are our last two examples. So on my first one here, I'm going to use the table method as well. This time, my second polynomial has 3 terms. So when I set up my table, I'm going to make sure that I have 2 columns for the 2 terms in my binomial and 3 rows for the 3 terms in my trinomial. So I've got g and -4 in my binomial, and I've got g squared, positive 3g, and -5 in my trinomial. So first I'm going to number my boxes. And I'm only numbering my boxes so that you know what I'm talking about since you can't see me point to it. I wouldn't normally number my boxes as I'm working through. So in box 1, I've got g times g squared, which gives me g cubed. In box 2, I've got -4 times g squared, which is -4g squared. Box 3, 3g times g is 3g squared. Box 4, I have -4 times 3g, which is -12g. Box 5 is g times -5, or -5g. And box 6 is -4 times -5, which is positive 20. So when I'm looking through for my like terms, box 1 has a g cubed with no like terms. Boxes 2 and 3 both have squares, so -4g squared plus 3g squared is -g squared, or -1g squared. Boxes 4 and 5 have g terms, negative 12g minus 5g is negative 17g, and box 6 has my positive 20. Alright, so the last one I'm going to use the distributive property again. So this time I'm going to distribute, I've got 3 terms in my first one, so I have to distribute all 3 of those terms to each of the 2 terms in my binomial. So I'm going to start with my x cubed times x squared. Remember, when we multiply powers, we add the exponents, they PERMDAS. X cubed times 3x gives me a positive 3x to the 4th. And then I have negative 7x times x squared is negative 7x cubed. And negative 7x times 3x is negative 21x squared. And finally, my last term, I've got 2 times x squared is positive 2x squared. And 2 times 3x is positive 6x. So then we look for our like terms. And I'm seeing x to the 5th has no like terms. 3x to the 4th has no like terms. Negative 7x cubed has no like terms. But I do have 2 squared terms, so negative 21x squared plus 2x squared is negative 19x squared. And my plus 6x has no like terms.